The lecture hall stretched wide and tall, filled with the strangest collection of beings Jake Morrison had ever seen in his 22 years of life. He sat in the third row, his simple human chair looking plain next to the specialized seating that accommodated his classmates. To his left sat a Krallian, its body made of living crystal that refracted the room's light into rainbow patterns. Behind him, 3 Vryn students connected to each other through thin biological cables, their collective mind allowing them to think as one. Across the aisle, a Threxian student floated in a containment field filled with methane gas, its tentacles moving in slow, deliberate patterns. This was the Andromeda Institute of Advanced Sciences, the most prestigious university in the entire galaxy. Only the best minds from hundreds of worlds could attend, and somehow, Jake had made it through the selection process. He was the only human in the advanced quantum mechanics class. In fact, he was one of only 12 humans studying at the Institute. Earth had joined the Galactic Council just 5 years ago, and most alien species still saw humans as newcomers, who barely understood the basics of space travel. Professor Velther entered through the main door, his crystalline body catching the light and filling the room with soft blue radiance. He was old, even by Krallian standards, having taught at the Institute for over 300 years. His reputation stretched across multiple star systems. Students considered it an honor just to attend his lectures, even though everyone knew. He maintained the highest standards and showed no mercy to those who fell behind. The professor moved to the front of the classroom and activated the holographic display. Symbols and equations materialized in the air, floating in 3-dimensional space. Jake recognized some of them from his preparatory studies, but many were completely new. He pulled out his datapad and prepared to take notes, aware that several alien students were watching him with what he assumed was curiosity, though reading alien expressions remained difficult. Velther began speaking, his voice resonating through translation devices that converted his crystalline vibrations into sounds each species could understand. He talked about multidimensional energy matrices, explaining how energy behaved differently across various dimensions of spacetime. The concepts were complex, requiring students to visualize spaces that human eyes could never see and to understand forces that defied everyday intuition. Jake listened carefully, his mind working to keep up with the flow of information. He had spent months preparing for this class, studying human physics and mathematics, while also learning the galactic standard approaches to these subjects. Humans did math differently than most alien species. They used shortcuts and approximations, finding answers that were good enough rather than perfect. In contrast, many alien civilizations had developed mathematics as a pure art form, valuing precision and completeness above all else. The lecture continued for nearly an hour. Professor Velther covered fundamental principles, historical developments in the field, and recent breakthroughs that had revolutionized faster-than-light travel. Jake's hand moved rapidly across his datapad, recording notes and sketching diagrams. He noticed that many alien students barely took notes at all. The Vryn collective simply absorbed the information and stored it in their shared memory. The Krallians had perfect recall and never forgot anything they experienced. Finally, the professor reached the main point of the day's session. He announced that he would be giving the class their first major assignment. The room filled with sounds of attention, various species expressing interest through their unique forms of communication. Velther explained that this assignment had been given to students for over 2 centuries, testing their understanding of the most fundamental aspects of advanced physics. The holographic display changed, showing a massive equation that filled the entire front of the classroom. Variables and constants spread across multiple lines, describing energy distribution across 11 dimensions of spacetime. The equation accounted for quantum fluctuations, temporal distortions, and the interaction of forces that humans had only theorized about until joining the galactic community. Jake stared at it, feeling both intimidated and excited. Professor Velther continued his explanation. The assignment required students to solve this equation completely, showing all their work and explaining their methodology. This particular problem formed the theoretical foundation for understanding how energy behaved during faster-than-light jumps. Solving it required deep understanding of multidimensional mathematics, quantum mechanics, and relativistic physics. Then came the part that made several students shift uncomfortably in their seats. The professor announced that students had one standard galactic week to complete the assignment. He noted that in all his years of teaching, even the brightest students required at least 4 days to solve it properly. Most students used the entire week, checking and rechecking their work to ensure accuracy. The problem was not just difficult, but also lengthy, requiring hundreds of calculations and careful attention to detail. Jake felt a weight settle in his stomach. 1 week seemed like a long time, but he had seen how complex the equation was. He wondered if his human brain, trained in different mathematical traditions, would even be capable of approaching the problem correctly. The other students seemed concerned, but not panicked. They had been raised in civilizations that had been solving such problems for thousands of years. The Krillian, next to Jake, turned slightly, its crystalline body shifting colors. Through his translation device, Jake heard a whispered comment clearly meant for him to hear. The Krillian suggested that perhaps the human should consider dropping the class before embarrassing himself. Several nearby students made sounds that Jake's translator interpreted as agreement or amusement. Jake said nothing in response. He had faced doubt before. When he applied to the Andromeda Institute, people on Earth told him he was wasting his time. When he was accepted, some said it was only because the galactic community wanted to appear inclusive to newer species. When he arrived on campus, other students treated him like a child playing in an adult's world. He had learned to ignore such comments and focus on his work. Professor Velther finished his lecture by reminding students that this assignment would count for a significant portion of their final grade. He encouraged them to work carefully and to seek help if needed, though he emphasized that the work must be their own. Collaboration was forbidden for this particular assignment. Each student needed to demonstrate their individual understanding. The lecture ended, and students began filing out of the classroom. Many immediately formed small groups in the hallway, discussing strategies for approaching the problem. Jake heard fragments of conversation as he gathered his belongings. Some students planned to spend the first 2 days just analyzing the equation structure. Others talked about booking time in the university's advanced computation centers. A few mentioned canceling their social activities for the week to focus entirely on the assignment. Jake walked out of the lecture hall alone, his datapad containing the full text of the assignment. He found a quiet bench in one of the campus gardens and sat down, pulling up the equation on his screen. Around him, alien plants from dozens of worlds created a landscape of strange colors and shapes. The evening sky showed unfamiliar constellations, reminding him of how far he was from home. He stared at the equation, letting his mind work through it without forcing anything. There was something familiar about its structure, though he could not immediately identify what. His human brain, shaped by evolution on a planet where quick thinking meant survival, began recognizing patterns in the chaos of symbols and numbers. Perhaps this would not be as impossible as it seemed. The next morning, Jake arrived at the lecture hall early. He wanted time to settle in before class started, to review his notes and prepare for whatever Professor Velther might discuss. Other students trickled in gradually, most looking tired already. Several carried multiple datapads, clearly having started work on the assignment immediately after the previous lecture. Jake took his usual seat in the third row and pulled out his datapad. He opened the assignment file and looked at the equation again. He had spent some time with it the night before, not trying to solve it, but simply letting his mind observe its structure. Now, in the morning light filtering through the lecture hall's transparent ceiling, he examined it more carefully. The equation was intimidating, no question about that. It sprawled across his screen in multiple lines, filled with symbols representing forces and dimensions that humans had only recently learned existed. But as Jake looked at it, something clicked in his mind. The structure reminded him of optimization problems he had studied back on Earth, the kind used in computer science and financial modeling. Professor Velther entered the classroom and began his lecture. Today's topic expanded on the previous day's material, providing additional context for the assignment. He discussed historical attempts to solve similar problems and explained common mistakes that students made. The lecture was helpful, but also made the assignment seem even more daunting. The professor emphasized how many different variables needed to be calculated, and how easy it was to make small errors that would cascade into completely wrong answers. As Velther spoke, Jake found his attention drifting back to the equation. He was not ignoring the lecture exactly, but part of his mind kept working on the problem independently. He started seeing connections between different parts of the equation, symmetries that might allow certain variables to be grouped together. His hand moved to his stylus almost unconsciously. The lecture continued, but Jake's focus had shifted entirely to his datapad now. He began writing, not random notes, but actual calculations. His approach was different from what Professor Velther was describing. Instead of carefully working through each variable one at a time, Jake was looking for patterns that would let him solve multiple variables simultaneously. Human mathematics had developed partly out of necessity. On Earth, humans often needed quick answers to survival questions. Which path was safer? How much food was needed? Where would the prey animal go? Over time, human brains had evolved to be very good at pattern recognition and making accurate guesses with incomplete information. This evolutionary pressure had shaped how humans approached mathematics itself. Jake's stylus moved rapidly across his datapad screen. He was applying techniques from chaos theory and pattern matching, mathematical fields that humans had developed to handle complex systems. While alien species approached the problem as a pure physics exercise requiring meticulous calculation, Jake was treating it as a puzzle where recognizing the underlying pattern was more important than calculating every single detail. 5 minutes had passed since Professor Velther had started his lecture. Jake set down his stylus and looked at his screen. He had filled several pages with calculations, moving from the initial equation through a series of transformations that simplified it dramatically. His final answer sat at the bottom of the last page, a set of values for all the variables the problem required. Jake read through his work carefully. He checked each step, making sure his logic was sound. The answer felt right, but he knew that feeling was not enough. He went through it again, more slowly this time, verifying each calculation. Mathematics did not care about intuition. Either the answer was correct or it was not. After his second review, Jake was confident. His method was unconventional by galactic standards, but the math was solid. He had used shortcuts that avoided hours of tedious calculation, but those shortcuts were based on sound mathematical principles. The symmetries he had identified were real, not imagined. Jake looked up from his datapad and realized that Professor Velther was still lecturing. The other students were focused on the professor or taking notes. Nobody had noticed that Jake had been working on the actual assignment during class. He glanced at the Vrin collective sitting behind him. Their shared consciousness was fully engaged with the lecture, absorbing every word. Jake made a decision. He stood up from his seat, his chair making a soft sound against the floor. Several students looked over, curious about why someone would move during a lecture. Jake picked up his datapad and walked toward the front of the classroom. His footsteps echoed slightly in the large space. Professor Velther paused in his lecture, his crystalline body shifting to face Jake. The attention of every student in the room turned to the human walking down the aisle. Jake could feel their eyes on him, could sense their confusion and curiosity. What was the human doing? Was he leaving class early? Did he have a question? Jake reached the professor's desk and stopped. He held out his datapad without saying a word. Professor Velther looked at the device, then at Jake, then back at the device. His crystalline features shifted through several colors. An expression that Jake's translator suggested indicated confusion mixed with annoyance. The professor took the datapad, clearly expecting this to be some kind of question or perhaps a request for clarification about the assignment. He glanced at the screen, and his body language changed immediately. The colors in his crystalline form shifted to patterns that indicated surprise and disbelief. The classroom had gone completely silent. Every student was watching the scene at the front of the room. Some had risen slightly in their seats to get a better view. The Vrin Collective had disconnected from their shared meditation on the lecture and focused their entire attention on what was happening. Professor Velther's voice came through the translation devices. Speaking directly to Jake, he asked if this was supposed to be a solution to the assignment. Jake nodded and replied that it was. He explained briefly that he had worked on it during the lecture and believed he had found the answer. The professor's crystalline body flickered through several colors rapidly, suggesting intense internal debate or emotion. He asked Jake how long he had spent on this solution. Jake checked his datapad's timestamp and answered honestly. 5 minutes, perhaps a bit more. A sound rippled through the classroom. Various species expressed shock and disbelief in their own ways. The Kralian next to Jake's empty seat made a sound like grinding glass. The Threxian student's tentacles waved frantically inside its containment field. Even the normally impassive Vrin Collective shifted in their seats, their biological connections pulsing with shared astonishment. Professor Velther held up one crystalline appendage, calling for silence. He announced that he would need to review this work before making any judgments. He suggested that Jake return to his seat while he examined the solution. There was an edge in his voice that the translator interpreted as skepticism. Jake walked back to his seat, aware of every eye tracking his movement. He sat down and tried to focus on the continuing lecture, but Professor Velther had clearly lost some of his concentration as well. The professor attempted to resume his discussion of the assignment, but his attention kept drifting to Jake's datapad, which he had placed on his desk. The lecture limped along for another 20 minutes before Velther finally gave up. He announced that class would end early today and that students should begin working on their assignments. As students gathered their belongings and left, Jake noticed many of them whispering and glancing in his direction. The Kralian, who had made the dismissive comment the previous day, approached Jake's desk. Through the translator, it asked if Jake had really solved the problem or if this was some kind of human joke. Jake replied calmly that he had solved it to the best of his ability and that the professor would verify whether it was correct. The Kralian made another grinding sound and walked away. Jake packed up his belongings and prepared to leave, but Professor Velther's voice stopped him. The professor asked Jake to remain behind after the other students had left. Jake nodded and settled back into his seat, his datapad in hand, while the last few students filed out of the lecture hall. Once they were alone, Professor Velther approached Jake's row and asked him to come to the front again. The professor wanted to discuss the solution in detail before running it through the verification systems. Jake walked forward, ready to explain his methodology and defend his unconventional approach to the problem. Professor Velther stood at his desk with Jake's datapad displayed on a large, holographic screen that filled the front of the lecture hall. The equation and solution floated in three-dimensional space, each line of calculation visible and clear. The professor's crystalline body had settled into a deep blue color, which Jake's translator suggested indicated serious concentration. The professor began at the beginning, reading through Jake's initial approach to the problem. His crystalline appendage traced along the first few lines of work, following the logic step by step. Jake stood nearby, waiting patiently. He had been in this position before, back on Earth, when teachers questioned his methods because they looked different from standard approaches. Walter paused at the third line of calculations. He turned to Jake and asked him to explain what he had done here. Jake stepped closer to the display and pointed to the specific section. He explained that he had recognized a symmetry in the equation that allowed him to group several variables together. Instead of calculating each one individually, he could solve for them as a set, which saved considerable time. The professor considered this explanation. He pulled up reference materials on his own system, checking mathematical principles that governed such groupings. After a moment, he acknowledged that Jake's approach was valid, though unusual. Most students would not have recognized that symmetry, especially not so quickly. He gestured for Jake to continue explaining. Jake walked the professor through his methodology. He described how he had treated the entire equation as a pattern recognition problem rather than a pure calculation exercise. He had looked for structures within the chaos, relationships between variables that were not immediately obvious but became clear when you step back and view the equation as a whole. Professor Walther listened carefully, occasionally interrupting to ask questions or to verify certain steps against his reference materials. Jake could see the professor's skepticism gradually shifting into something else, though he could not quite identify what emotion the color changes represented. The verification process was taking much longer than the original solution had taken. At one point, the professor pulled up a standard solution to the problem, one that had been accepted as correct for decades. He displayed it next to Jake's work, comparing the two approaches side by side. The standard solution was much longer, filled with pages of detailed calculations that methodically worked through each variable one at a time. It was thorough, precise, and complete. It was also exactly the kind of approach that would take a student days to complete. Jake's solution was shorter by comparison. It jumped over several steps that the standard solution included, not because Jake had skipped the work, but because his pattern recognition approach made those steps unnecessary. He had found a more direct path to the answer by recognizing underlying structures that the standard approach did not acknowledge. Walther asked Jake where he had learned this technique. Jake explained that it came from human mathematics, particularly fields like chaos theory and optimization algorithms. He described how humans often needed to solve complex problems quickly, without having time to calculate every detail perfectly. This practical necessity had led to mathematical methods that prioritized finding good solutions fast over finding perfect solutions slowly. The professor found this explanation troubling. He asked how humans could trust such methods if they did not calculate everything precisely. Jake responded that humans verified their intuitive leaps through testing and refinement. If a quick solution worked, it was adopted. If it failed, it was modified. Over time, humans had developed reliable techniques for making accurate estimates and recognizing meaningful patterns. Professor Walther returned to examining the solution. He worked through the middle sections, where Jake's calculations became more complex. Here, Jake had applied techniques from what humans called heuristic problem solving, using rules of thumb and educated guesses to navigate through particularly difficult portions of the equation. Each guess was mathematically justified, but the approach was fundamentally different from the methodical calculation that galactic mathematics typically employed. 20 minutes passed, then 30. Jake remained standing near the front of the lecture hall, answering questions when asked, but otherwise staying quiet. He watched the professor work, seeing the careful attention to detail, the frequent consultations with reference materials, the occasional color shifts that suggested surprise or reconsideration. Finally, Professor Velther announced that he was ready to run the solution through the verification system. This was a computer program that checked mathematical work against known correct answers and evaluated the validity of each step. The professor entered Jake's solution into the system and activated the verification protocol. The holographic display filled with scrolling data as the system analyzed the work. Jake felt his heart beating faster. He was confident in his solution, but confidence and correctness were not always the same thing. If he had made an error, if his pattern recognition had led him astray somewhere, it would become clear now. The verification system completed its analysis. Results appeared on the screen in symbols that Jake had learned to read during his preparatory studies. The solution was correct. Every variable had been solved accurately. The final answer matched the known correct solution exactly. But the verification system showed something else as well. It rated the efficiency and elegance of the solution method. This was a standard feature, used to help students understand not just whether their answer was right, but whether their approach was optimal. Jake's solution received ratings that made Professor Velther's crystalline body flash through several colors in rapid succession. The system rated Jake's method as more efficient than the standard approach by a significant margin. It identified the pattern recognition techniques as valid mathematical operations that reduced computational complexity without sacrificing accuracy. In the elegance rating, which measured how direct and clean a solution path was, Jake's work scored higher than the traditional method that had been taught for decades. Professor Velther stood silent for a long moment, staring at the verification results. Jake waited, unsure what to say or do. The professor finally turned to face him, his crystalline features settling into a pattern that the translator struggled to interpret clearly, suggesting an emotion or combination of emotions that did not have a direct human equivalent. The professor spoke, his voice carrying a tone that seemed to blend respect with confusion. He told Jake that the solution was not only correct but remarkably well constructed. He admitted that in his 300 years of teaching, he had never seen a student solve this problem in 5 minutes. More than that, he had never seen an approach quite like Jake's. Jake felt relief wash over him but kept his expression neutral. He thanked the professor for taking the time to verify the work thoroughly. He asked if there were any issues with his methodology, anything he should change or improve for future assignments. Velther considered the question carefully. He explained that there were no errors in Jake's work, no violations of mathematical principles. However, the approach was so different from standard galactic methods that it raised important questions. How widely applicable were these human techniques? Could they be taught to other species, or were they dependent on specifically human cognitive traits? The professor made a decision that surprised Jake. He announced that he wanted to spend the remainder of the week exploring Jake's solution method with the entire class. Instead of having students work independently on the assignment, he would turn it into a collaborative learning experience. Jake would present his approach, explain his reasoning, and help other students understand how pattern recognition and heuristic methods could be applied to complex problems. Jake agreed. Though the prospect of teaching a class full of alien students from civilizations far older than humanity was intimidating, Professor Velther assured him that this was an honor, not a burden. The professor emphasized that Jake had demonstrated something valuable, and that value should be shared with others. The professor dismissed Jake, telling him to prepare a presentation for the next class session. As Jake gathered his things and walked toward the lecture hall exit, he felt a strange mixture of pride and uncertainty. He had proven that his solution was correct, But he had also challenged assumptions that galactic civilization had held for centuries. He was not sure how other students would react to that challenge. Outside the lecture hall, Jake found several students waiting. Word had apparently spread that the human had submitted a solution after only 5 minutes of work. Some students looked skeptical, others curious. One student, a Threxian named Clicks, approached Jake and asked directly whether the solution had been verified as correct. Jake confirmed that it had been. The professor had checked it thoroughly and run it through the verification system. The answer was right. Clicks's tentacles waved in a pattern that suggested surprise and interest. The Threxian asked if Jake would be willing to discuss his methods informally. Jake agreed, and soon found himself surrounded by a small group of students asking questions about human mathematics, pattern recognition, and problem-solving strategies. Not all the students were F. The lecture hall filled with students earlier than usual. News had spread across campus about the human who solved a week-long assignment in 5 minutes. Some students came out of genuine curiosity, wanting to understand how such a thing was possible. Others came skeptical, convinced there must be some trick or error that Professor Velther had missed. A few came simply because missing this lecture would mean missing what promised to be memorable. Jake sat in the front row now, his datapad loaded with the presentation he had prepared over the past day. He had worked hard to organize his thoughts, to find ways to explain human mathematical concepts to minds that thought in fundamentally different ways. Professor Velther had helped him prepare, offering suggestions on how to present complex ideas to such a diverse audience. The professor entered and called the class to order. His crystalline body glowed with a warm amber color, which Jake had learned indicated enthusiasm and anticipation. Velther began by explaining that today's session would be different from typical lectures. Instead of him teaching, a student would present an alternative approach to problem solving that had proven both valid and remarkably efficient. Several students shifted in their seats at this announcement. The Kralian who had dismissed Jake on the first day made a grinding sound that suggested displeasure. But Professor Velther's ever-obese reputation commanded respect, and the classroom settled into attentive silence as Jake stood and walked to the front. Jake began his presentation by displaying the original equation on the holographic screen. He acknowledged that this problem was complex and challenging, requiring deep understanding of multidimensional physics. Then he asked a question that seemed to confuse many students. He asked them how they had planned to approach the problem. Several students volunteered their intended strategies. The Vrin Collective described a methodical process of calculating each variable in sequence, building toward the final answer through systematic progression. A Kralian explained a similar approach but emphasized the importance of perfect precision at each step. A student from the Drellin Confederacy mentioned planning to use quantum computation, matrices to handle the dimensional calculations. Jake listened to each response and thanked them for sharing. Then he explained that all these approaches had something in common. They treated the problem as a calculation exercise, something to be solved through careful, step-by-step work. He suggested that there might be another way to think about it, a way that started not with calculation, but with observation. He walked them through his initial analysis of the equation. He showed how he had not immediately begun calculating, but had instead spent time simply looking at the structure of the problem. He highlighted symmetries in the equation, places where variables related to each other in predictable ways. He pointed out patterns that repeated across different sections. Some students began to see what he meant. Others looked confused, their alien minds struggling with this approach. The Vrin Collective asked how one could solve a problem by observation. Observation was for gathering data, not for mathematics. Jake explained that observation was exactly where mathematics started for humans. Before calculating anything, humans tried to understand the shape and structure of what they were dealing with. Jake then introduced the concept of pattern recognition. He explained how human brains had evolved to find patterns quickly, a survival skill that had later been applied to mathematics. He described how humans could often recognize similarities between different problems, allowing them to apply solutions from one context to another. This concept troubled many students. Aurelian raised an objection, arguing that each problem was unique and required its own specific solution. Jake acknowledged this was sometimes true, but he suggested that many problems shared underlying structures. If you could recognize those structures, you could solve entire categories of problems using similar approaches. To demonstrate, Jake showed how he had recognized that parts of the quantum mechanics equation resembled optimization problems from human computer science. The specific content was different, but the mathematical structure was similar. This similarity allowed him to apply techniques from one field to another, finding solutions more quickly than traditional methods would allow. Professor Velthor interjected at this point, adding context for the students. He explained that what Jake described was not actually new to galactic mathematics. Advanced mathematicians across many species had occasionally noted such similarities. However, it was considered an interesting observation rather than a practical tool. Most species taught mathematics as a pure discipline, emphasizing precision and completeness over speed or efficiency. Jake continued his presentation, walking the class through his actual solution step by step. He showed how he had grouped variables based on symmetries, reducing the number of independent calculations required. He demonstrated the heuristic shortcuts he had used, explaining the mathematical principles that made them valid. He acknowledged that his approach involved educated guesses, but he emphasized that these guesses were grounded in solid mathematical reasoning. The presentation lasted nearly an hour. Jake fielded questions throughout, doing his best to explain human thinking to alien minds. Some questions were hostile, implying that his method was sloppy or unreliable. Others were genuinely curious, seeking to understand the cognitive processes behind pattern recognition. When Jake finished, Professor Velthor opened the floor for broader discussion. The response was mixed and passionate. Several students argued that Jake's approach, while interesting, represented a step backward. Mathematics had evolved toward precision and completeness, precisely because these qualities made knowledge reliable and transferable. Accepting approximations and intuitive leaps would undermine the foundations of scientific truth. Other students defended Jake's methods. Clix, the Threxian student who had shown early interest, pointed out that efficiency mattered. If two methods produced the same correct answer, but one took 5 minutes and the other took 5 days, the faster method had clear advantages. In practical applications, like engineering or real-time calculations during space travel, speed could be crucial. A heated debate erupted. The Vrim Collective argued that their species' computational abilities meant they did not need shortcuts. They could calculate precisely and quickly through their shared consciousness. Aurelian countered that lifespan also mattered. Species that lived for centuries could afford to spend days on a single problem. Younger species with shorter lifespans might need faster methods simply to accomplish the same amount of work in their available time. Professor Velthor led the debate, continued for some time before calling for order. He acknowledged that there are valid points on all sides. Then he made an observation that shifted the conversation. He noted that humans had evolved on a relatively dangerous planet where quick decisions often meant the difference between survival and death. This evolutionary pressure had shaped how human brains processed information, favoring fast pattern recognition over slow, careful analysis. The professor suggested this was not a weakness, but simply a different evolutionary path. Most galactic species had developed their mathematics during peaceful periods, when survival was secure and scholars had time to think deeply. Humans had developed their mathematics while still struggling to survive, creating tools that worked under pressure and with incomplete information. This observation led to a new line of discussion. Students began considering how evolutionary history shaped thinking patterns. The Vryn Collective acknowledged that their species' development of neural networking had occurred during a period of planetary crisis, when individual survival depended on group coordination. The Kralians noted that their crystalline biology, with its perfect memory and long lifespan, naturally led to value in precision and completeness. Jake listened to these discussions with fascination. He had not considered how deeply evolution influenced mathematics itself. He had simply learned the methods that humans had developed and applied them to the problems he faced. Now he was seeing those methods in a broader context, understanding them as products of Earth's particular challenges and humanity's specific solutions. As the class session neared its end, Professor Velther announced his decision about the assignment. Given what had been discussed, he was modifying the requirements. Students could still complete the assignment using traditional methods if they preferred. However, he would also accept solutions that incorporated pattern recognition and heuristic approaches, as long as students could explain and justify their reasoning. Several students objected to this change, arguing that it lowered standards. The professor responded firmly. He stated that the goal of education was to develop thinking skills, not to enforce a single method. If students could demonstrate understanding through different approaches, those approaches should be accepted. The universe was vast and complex, and it would require many different types of thinking to fully. The lecture ended with the classroom buzzing with conversation. Students clustered in groups, debating the merits of different approaches. Jake found himself surrounded again by curious students asking detailed questions about human mathematics. Not everyone was convinced, but enough students showed genuine. 3 weeks had passed since Jake's presentation, and the Andromeda Institute campus felt different to him now. Students who had previously ignored him now stopped to ask questions about human problem-solving methods. Professors from other departments invited him to guest lecture in their classes. The Institute's academic journal requested an article describing his approach to the quantum mechanics assignment. What had started as a single surprising moment had grown into something larger. Professor Velther had restructured his entire curriculum based on what he had learned. The quantum mechanics course now included units on multiple problem-solving methodologies, presenting galactic standard approaches alongside alternatives like pattern recognition and heuristic reasoning. Some students embraced these new options enthusiastically. Others resisted, clinging to traditional methods they trusted. But everyone was at least exposed to the idea that there were multiple valid paths to truth. Jake sat in the campus library working on his next assignment when Clix approached his table. The Threxian's tentacles moved in patterns that Jake had learned to recognize as excitement. Clix explained that his own research project, which had been stalled for 3 months, had suddenly made progress. He had applied Jake's pattern recognition approach to a problem in stellar formation dynamics and found a solution that had eluded him using traditional methods. This was not an isolated incident. Over the past few weeks, Jake had heard similar stories from nearly a dozen students. They had taken the concepts from his presentation and applied them to their own work in various fields. Some attempts failed, but enough succeeded that word spread quickly. Human mathematical techniques were not just theoretical curiosities, but practical tools that could solve real problems. The academic community beyond the Institute had taken notice as well. Professor Velther had submitted a paper to the Galactic Journal of Sciences describing Jake's solution and its implications for mathematical education. The paper argued that galactic civilization had become overly focused on a single approach to problem solving, valuing precision and completeness while neglecting efficiency and adaptability. The paper suggested that humanity's late arrival to the galactic community might actually be an advantage, bringing fresh perspectives unburdened by centuries of established tradition. The paper created controversy. Senior scholars from prestigious institutions across multiple star systems published responses defending traditional methods. They argued that precision was not optional in mathematics, but essential. They worried that encouraging shortcuts and approximations would lead to sloppy thinking and unreliable results. Some responses carried an unmistakable tone of dismissal, suggesting that humans simply lacked the intellectual capacity for true mathematical rigor. But other scholars responded more positively. A team of researchers from the Drellin Confederacy replicated Jake's approach on a series of complex problems, comparing results with traditional methods. Their findings showed that pattern recognition techniques produce correct answers more than 80% of the time while requiring significantly less calculation. For certain types of problems, particularly those involving symmetries and repeated structures, the efficiency gains were dramatic. A conference was organized to discuss these findings. The Andromeda Institute hosted scholars from across the galaxy for a week-long symposium on mathematical methodologies. Jake attended several sessions, watching as beings from dozens of species debated the nature of mathematics itself. The discussions were fascinating and sometimes heated, revealing deep philosophical divisions about what mathematics was for and how it should be taught. During one memorable session, an elderly Kralian scholar gave a presentation defending traditional approaches. The scholar argued that mathematics was about discovering eternal truths, not about solving problems quickly. Speed and efficiency were engineering concerns, not mathematical ones. True understanding required working through every step carefully, leaving nothing to intuition or approximation. A younger scholar from the Vrin Collective responded with a different perspective. She argued that mathematics was a tool created by minds to understand the universe. Different minds, shaped by different evolutionary pressures, would naturally create different tools. Rather than declaring one approach superior, galactic civilization should embrace diversity in mathematical thinking, just as it embraced diversity in biology and culture. Jake found himself agreeing with this second perspective. He had never thought his methods were better than galactic standard approaches, just different. Both had strengths and weaknesses. The ideal situation would be for mathematicians to have multiple tools available and to choose the right tool for each specific problem. On the fourth day of the conference, Jake was invited to give a presentation himself. He spoke to an audience of several hundred scholars about human mathematical development. He explained how Earth's hostile environment and humanity's relatively recent technological development had shaped mathematical thinking. He described the practical problems that had driven mathematical innovation on Earth. From navigation to engineering to economics. The presentation was well received, though Jake could sense skepticism from some audience members. During the question period, a Kralian scholar asked whether humans had developed any truly original mathematics or whether they had simply rediscovered techniques that galactic civilization had long since moved beyond. Jake admitted honestly that he did not know the complete history of galactic mathematics. Perhaps some of what humans considered innovative had been explored before. Professor Velther stood to respond to this question. He acknowledged that some human techniques had historical precedence in galactic mathematics. However, humans had systematized these techniques in ways that previous civilizations had not. They had made pattern recognition and heuristic reasoning central to their mathematical education rather than treating them as interesting side notes. This focus made a practical difference in how problems were approached and solved. The conference concluded with a resolution that surprised many attendees. The Galactic Institute of Mathematics, which set educational standards across member worlds, announced that it would revise its curriculum guidelines to include alternative problem-solving methodologies. The revised guidelines would not make these alternatives mandatory, but would strongly encourage their inclusion alongside traditional approaches. Students throughout galactic space would now learn that there are multiple valid ways to think about mathematics. Jake returned to his regular classes after the conference, but those classes had changed. Professors incorporated examples from multiple mathematical traditions into their lectures. Students discussed trade-offs between precision and efficiency when choosing solution methods. The rigid certainty that had characterized galactic mathematics education began to soften, replaced by a more flexible understanding that acknowledged different strengths and different situations. 6 months after, Jake solved the quantum mechanics problem in 5 minutes. He received a message from Earth. The message came from the Office of Galactic Relations, a government agency responsible for managing Earth's integration into the galactic community. The office was recruiting more humans to attend the Andromeda Institute and other galactic universities. The agency had realized that humans had unique contributions to make to galactic knowledge, and they wanted to accelerate human participation in academic institutions. The message specifically mentioned Jake by name. His success had inspired confidence that humans could compete at the highest levels of galactic academia. More importantly, his demonstration that human approaches to problem-solving had practical value had changed how other species viewed humanity. Earth was no longer seen as just a newcomer learning from older civilizations, but as a civilization with its own valuable knowledge to share. Jake replied to the message, offering to help with recruitment and orientation for new human students. He remembered how isolated and uncertain he had felt when he first arrived at the institute. If he could make the transition easier for others, that seemed worthwhile. The agency accepted his offer, and Jake found himself with a new role as an informal advisor to incoming human students. As the academic year continued, Jake watched the changes spreading through the institute. The debate about mathematical methods gradually expanded into broader discussions about knowledge itself. If there were multiple valid approaches to mathematics, perhaps there were multiple valid approaches to other fields as well. Physics, engineering, even philosophy began to incorporate alternative perspectives more deliberately. Jake completed his first year at the Andromeda Institute with high marks in all his courses. More importantly, he had found a place within the galactic academic community. He was no longer just a human student trying to keep up, but a contributor whose perspectives were valued. The other students who had dismissed him at the beginning of the year now sought his collaboration. Professor Velther told Jake privately that his impact on the Institute would be felt for decades. By challenging the assumption that there was only one correct way to approach problems, Jake had opened space for innovation and creativity. The professor predicted that this would lead to breakthroughs across multiple fields as researchers